Hey everybody, it's Tony from Adafruit, and things probably look a little bit different. So got a haircut. Sometimes the hair starts going, so it's just if it's gonna go, it's gonna go on my terms. So just buzz it a little bit short. And I've got a new camera upgrade, so you're watching this through a little mirrorless camera that's got a little bit better quality. So hopefully the picture is a little bit improved. So I wanted to start a new little series, maybe another 3 parts of video series again on Internet of Things with the Raspberry Pi. So the Pi is a really great platform for building a thing, which could be anything, just a device. Maybe it controls some other hardware. Maybe it has sensors that you want to read. Maybe you're controlling like motors and stuff like that. Some kind of thing, and internet enabled in the sense that you can control it from a web browser or a web page. So being able to just open up a web page, go to your Raspberry Pi and turn on an LED or read the state of a switch. Real kind of interesting thing like that. And so in this first video I was thinking, let's just do the hello world of Internet of Things, to blink an LED with a web page. But I'll walk through and we'll do it all in Python, and I'll show you how you can build a little web application in Python. Use some really nice little frameworks like Flask, that's a web framework that's very simple and easy to use. And you'll kind of see just how with very little code you can create some of these really interesting devices. So in this first video, we'll start with just the hello world, like blink an LED and read a switch on a web page. And then in later videos, we'll kind of extend this and go further and see, can we do things like real time with web sockets and, get as fancy as we want with it. So let's see, we'll jump in and I'll do a quick little demo first to just kind of show you, what we're going to build in this first video. And then we'll kind of go from there and just dive in and create it. So let me switch to the desktop view here. So yeah, we'll do this kind of three view setup. So on the left here, this is just the web browser, and it's actually running. So I have a Raspberry Pi up in the corner up here. This is the Pi 3, but you could use any Pi. There's no requirement here that this has to work on the Pi 3. And then I have a little LED connected to this. And I have a switch, but it's not really a switch. I just have this white wire is an input to the Raspberry Pi. And then I have just power, 3.3 volt power and ground as other wires that are connected here. So if I move this white wire between power and ground, it's effectively like turning the switch on and off. Like think of it like a slide switch. Actually, I had a slide switch hooked up to this, but something's broken in it. It's shorting out the power and the ground. So let's, we'll just use wires for now. But basically, so you see I have a little web page. This is being served from the Raspberry Pi. So there's a little web server on here. It's actually Python code that's running this. And so when I go to this website, it's telling me the switch is off, so it's connected to ground. And then there's a couple buttons here, LED on and LED off. So if I click LED on, you can see the LED turns on right here, this little red LED. And when I click LED off, turns off like that. So pretty cool, basic hello world, but shows 2 different things here. And actually, let me change the switch. So I'll move it from ground to 3.3 volt power, and when I refresh the page, now you see switch is on right here. So it's reading the state of the switch. It's not fancy, it's not like doing a real-time kind of WebSocket thing and instantly updating, but we'll get to that eventually. We'll do that maybe in later videos. But this is just showing okay, I'm able to read data from the Raspberry Pi. Like when I load the page, it tells me if the switch is on or off, and I'm also able to send data, like to set the state of things, and pretty easily just with the button presses here. And so we'll go through, I'll kind of show you, just kind of as a beginner to like Python and Flask and web apps and things. I'll try to explain kind of in detail what we're doing, but really it's not as much code as you might think. Like there's really just, maybe 30 or 40 lines of code to get this basic thing going for this. So, and also maybe before I get kind of too far into it, I have the code for this up on GitHub. And for each of the parts, I'll keep adding this code. So it's under this repository. When this video is on YouTube, in the description, look down below, and I'll have links to this repository and all kinds of stuff. Also, I'll put in links because I'm sure people might be kind of interested. I'll mention what camera gear I'm using now too to get kind of the nicer little shots and things here. So this is the repository, and it has all the code. And as I add more parts to this, I'll add more to it. But it's pretty straightforward, and I've got a few little instructions on what to do for this. So I think we'll just dive in, and I'll just kind of start from scratch and show you how we're going to create this whole thing. So let me just close out of what was running on the Pi, and I'll go back up and we'll make a new directory. So So I've got my Raspberry Pi. I just loaded it up with the Raspbian Jessie operating system. I'm actually using Jessie Lite, which is kind of the lightweight one without a desktop, because I'm not going to use the desktop environment, so I can use this. I just noticed today, 3.18, there's a brand new Raspbian image, so I just grabbed that and I'm running that. Looks like they just kind of updated the kernel. I think it's like some Pi 3 tweaks and things. But I'm connected to it through SSH. I also have the Raspberry Pi mounted using this. Oh, I don't have it actually mounted yet, so let me mount the Pi. So this is a neat little tool called Mac Fusion that lets you mount the Raspberry Pi as a drive on your Macintosh machine here. So then once I have it mounted, I can actually open up my text editor. So I'll open up the Atom editor, and then I can connect my Raspberry Pi. So if I go to open and open up my Raspberry Pi, then we'll actually see the whole file system for the Pi. So let me just drag this over. So this is just showing the files on the Pi. So from the Pi, let's go back to this in the terminal session, and let's just make a new directory. We'll call this part 1 inside of here, and I'll change into here, and there's nothing in here yet, but we'll start with the code for this. So what I want to do, maybe I'll start with, we'll just make a basic little web application with the Flask framework, and we'll literally just use their starting example. It's super small and easy to kind of get started with. So let's first create a directory. I'm going to put the web app in a directory called web app, just because as I create this, there's more than just the web app. Like there's, you know, some little Python code that I want to create. There's like a little test application. There's a systemd service file I'm going to create that I'll show you. Like that's how I can make something start on boot. So you know, I like to kind of separate things out. Like I could just throw everything into a directory, but it's easier if I just, you know, as this thing grows, it'll be easier to maintain as I, you know, if I separate things out. So I'll make a web app directory, and then let's go back to the Pi, and let me just refresh. So here's that part 1 directory. Here's the web app directory. And inside of here, I'm going to make a new Python file. So let's do a new file, and let's call this main.py. And what I'm going to do, so the framework I'm going to use to create the web application is called Flask. And there are a lot of different web frameworks in Python. There's no best framework. Like there's just, each one does things in a little different way, and they all have advantages and disadvantages. Flask is nice in that it's simple. So like if you only need to just render web pages and maybe do some basic templates and stuff like that, it'll give you that. And then you can add on lots of more extras. You know, if you need like a database backend, there are plugins you can use for that. This is kind of in contrast to a more full stack framework. Like Django is a real popular one where it creates a database and helps you create a data model, and all of that stuff is super useful, but it's just sometimes a little more than you need for this. So, you know, I don't have anything like a database that I care about yet, so I'm just going to use Flask here to start with. And one of the big reasons I like Flask is, if you look at this is their kind of hello world example for how to create a little web page. And it's, you know, only like 6 or 7 lines here of code. So let's just paste this in, and we'll just start with this and kind of evolve it as we go. There's one little tweak I'm going to make. So in this app.run, I'm going to change the host to 0.0.0.0. The reason I'm doing this is because if I don't do this in this app.run, I can only access this web page from the Raspberry Pi. Like by default, it tries to be a little bit secure and just run its web server only accessible from the machine that it's running on. But if I change this host to the 0.0.0.0, then that just means run this server and listen for connections from anybody. So it could be a connection from the Raspberry Pi back to itself, or it could be a connection from like my Macintosh machine, you know, another machine on my network that can come in and access this web page. So that's one little tweak. And then the other thing is I'm going to turn the debug mode on. So I'll do debug equals true. And so kind of the way Flask works, you do some kind of boilerplate to import it. So you import the Flask library, you create a little Flask application, and then you create routes. And so a route is just like a path on the web page. And a route can do anything. Like it could just render a web page, or it could be an API that changes things. So it could be, you know, like turning an LED on or turning it off, for example. So this one just starts with just a default route. So if you just go to, you know, Raspberry Pi / with nothing else after it, it's going to render this hello world data, basically. Like there's not even a template. It's not even HTML. It's going to return back hello world. And then this last little part is just when this code is run with the Python interpreter, it's just going to tell Flask to run my application. and it uses a little built-in web server. Now you can get a lot more advanced, and like Python has kind of purpose-built web servers that are more high performance. But for now, we're fine to just use this debugging server. I mean, just for a simple kind of usage of Raspberry Pi on a network like this, it's really all you need. You don't need to get more advanced than this. So I saved this file, and let's go back to the Pi. And let's see, we should see, yeah, there's the file there. So let's just run this, python main.py. And you can see, okay, so I'm running, and it's telling me that it's running on 0000 port 5000. So that's kind of important. It's good to know that the default port is 5000. So like normally when you go to a website like, google.com or adafruit.com, that's using port 80. So that's kind of the default web port, but you can change that. If you put a colon there, you can change to a different port. And the port is really just a number. So like some ports are standard, like the web uses port 80 for unencrypted traffic. For encrypted traffic with SSL, it uses port 443. So, a lot of those ports are kind of predefined. And then beyond like 1,000 or so, you can kind of just make up and use any ports. So Flask decides to use port 5000. So, we'll use that. That's fine. I could, and you can change in the config for Flask, if you want to use like port 80, for example, and make this a web server that you can access without specifying the port. So it's just telling me that debugger is active, and that's just useful. You'll see, I'm sure I'll probably make some errors and things, and it's useful to turn the debugger on because it'll kind of give you the stack trace and tell you, okay, something went wrong. So we'll go through and we'll see what happens now when I access this. So it's running. Now if I go to my web browser, and if I open up HTTP Raspberry Pi :5000, so this is basically the address of my Raspberry Pi, just the host name of it, and then the port that the server is running on. And I'll just put / here, but the web browser would actually automatically add that if I didn't have it. So I'll hit enter, and cool, it says hello world. So there's our output, so you can directly see. So, and I can actually change this. So if I go back to my script and I say, okay, hello world from Raspberry Pi, and then I save this. Now here's a really cool thing about Flask. When I go back here, you'll see detected change in main.py reloading. So its default web server is pretty smart, and it actually monitors the files, and it knows when you change your code, it'll reload it, so you automatically see that change. So I don't need to restart the server. It picked up the change, so I just go back and I reload the page, and hello world from Raspberry Pi. So that's pretty cool, pretty easy to see. And like I was saying, the route is just defining where along that path this function is called. So I can actually change this, like if I do /foo, and if I save this, now it's going to reload the server. Now I'm going to hit enter, and we'll see what happens. So it says not found because there's no route under that /path anymore. But if I go to /foo, now we see hello world from the Raspberry Pi. So really powerful thing. Like pretty much every web application is just all about defining these routes. Like different resources, you can expose them under different routes like this. And you can get really advanced. You can pass parameters around, and we'll kind of see some of this a little bit later. But for most web apps, you probably want some kind of a default route that says, okay, the user hit this main page and render something, like give them something useful to see. Right now, we're just returning text, and text is not as useful. We probably want to render like an HTML page. And this is another nice thing that Flask can do for us. So if we make a few changes here, so I'm actually going to change this import to just import everything from the Flask library. And the reason I'm doing this is because I want to use this little render template function that Flask has. So if I call render template, and we'll say index.html, then this is telling Flask to take a file called index.html and render it and actually return it as the result. And the way that we actually define that file, we have to create a new directory. So in this web app directory, we make a new folder called templates. And this is a convention in Flask. So Flask, it tries to be kind of like Ruby on Rails and some of these web frameworks where it's more convention over configuration, where, in some web frameworks you have to like laboriously define sometimes like this nasty XML file that says, here's every route, here's every file. Whereas Flask just says, well, we know that you usually want to define templates. So if you have a folder called templates, we're going to look there first for our templates. And so inside of here, now we create a new file, and we can create index.html. And this can be any kind of HTML file. What I'll do is I'll actually show you what I kind of like to start with. And for this first example, like you could see, the HTML was really basic and bare bones. But in later videos, I'll maybe kind of show you some tricks on how to make a little bit prettier output, like using frameworks like Bootstrap and some of these systems. Now, I should preface this all. I am not a web developer. I am not a front-end person. I know just enough to be dangerous, so I might do things that aren't the best kind of practice, but I'm just kind of trying to show you what I've learned and what works well. What I like to do is I like to go to this site, html5boilerplate.com, and this kind of gives you a default little, here is a basic web page to start with. And I do this because HTML has evolved. I mean, it's like 30 years old, probably almost, maybe 20 years old. And it's changed a lot. So if you search for like, how to get started with HTML, you might find something that's 10 years old that's telling you to design a site using tables and all of these things that aren't really modern HTML. So I like to start with this boilerplate because it's basically, a lot of people who are smarter than me about front-end development have gotten together and said, let's make a basic example that's, someone like me who doesn't really know a lot about front-end development can use this as a starting point to get going. So I download this and I'll open it up, and actually I already have it here, and it comes as just a bunch of files. But the one that I care about is this index.html here. So if I drag this into the Atom text editor, this loads up the boilerplate index, and you can see it's kind of advanced. Like if you're not familiar with HTML5 and you've used HTML in the past, a lot of stuff has changed. So this doc type is kind of the standard way to say this is an HTML5 website. There's no more of this crazy XML namespace stuff anymore. Luckily, we've kind of gotten that all out of our system. But there's a lot of stuff kind of going on here. Now, I'm going to copy out the code for this, and I'm going to drop it into my index.html, and I'm just going to close this. Now, there's a few things I'm going to delete from this because the boilerplate it's nice in that it gets you started with some good stuff, but it might give you a little bit more than you need. So, like for example, it uses this normalize.css, and it assumes that you have your own main CSS style sheet, and I don't have any style sheets, so for now I'm just going to pull these out. It's pulling in this modernizer, which is like a little JavaScript code that kind of standardizes your web browser, because another big problem with web pages is browsers have also evolved over the last 20 years, and so a big question is like, which browsers do you support? Do you go back and support like Netscape version 2.0? I don't think anyone uses that anymore, but I remember that was one of the first web browsers I started using. These days I think like IE8 is kind of the baseline for what people support, and then like Chrome and Firefox and those things too. So Modernizer basically tries to go back and like smooth over all the edges, because every browser has bugs in how it supports different things, and people have kind of found over time that it's easier to try and fix those bugs and make things consistent than trying to have all these little conditions in your code that are like, okay, if it's IE8, render it this way. If it's Firefox, render it this way. But I'm going to throw that out for now because we don't need it right now. We're just kind of keeping things simple. I'm going to pull out this Apple Touch icon. I'm guessing this is some mobile thing. I don't use it. I don't need it, so it's fine. In the body here, it looks like it does do a little check to see if you're running less than IE version 8. It gives you a little nag screen that says, hey, you should go update, so I'll keep that in. That's fine. And then it has some code in here, so like a little hello world. And then this code is actually a little bit of weird stuff, but these top two lines are basically loading up jQuery. And jQuery is like a really popular JavaScript library. It kind of changed how a lot of front-end development is done, in that it gave you a lot of good functions and easy ways to write code that runs across a lot of different browsers. I mean, almost every web page today uses jQuery in some way. It's a little contentious. Some people don't like it. It's big. It has a lot of stuff in it. There are alternatives to it, but I'm going to keep it because I'll show you that it actually does make our life a little bit easier for some things that we want to do with this example. Now it pulls in a few other JavaScript files, like this plugin and a main JavaScript. I don't have these, so I'm going to pull them out. I'm going to delete them. And then the very last thing is some Google Analytics stuff, where I'm going to pull this out because if you have a Google Analytics account, then you can hook in and put your key in there, and it'll give you all these really cool stats. But we're just building a little demo, so we don't really need this. So I'm going to save this. So I saved that index.html. It's in my templates folder. So my main.py now, it calls that render template, and it references index.html. And notice it doesn't have to render, like templates/index.html. Like, it knows that it should look in the templates folder. And now it's picked up that change. So if I reload my web page here, then we should see, and I'm not going to go to /foo, I'm going to go back to the root. Then something exploded. So okay, so it's telling me basically, and this is why I turned the debug mode on, because it's kind of useful to have this. So view function did not return a response, and that's because I probably need to return this render template call and not just call render template. So I fixed that, and let's try reloading, and let's see if this fixes our error. So yep, looks like it works. So it says this is HTML5 boilerplate. So this is kind of our boilerplate example, and that's just rendering exactly our index.html in here. So okay, that's cool. So we've got kind of a basic web page for this. So now maybe let me switch gears, and we'll do the Python code to talk to the switch and change the LED, and I'll do that in isolation from our web page. We'll come back and I'll show you how to fit that into the web page here. So let's make a new Python file, and I'm not gonna, or actually yeah, I will put this in the web app directory, and I'm gonna call this thing.py. And basically this is where I'm gonna put my internet thing code. So this is the code that's gonna talk to hardware and do something interesting. And so I'll have my web app reference this thing.py and call functions and stuff inside of here. And then I'll be able to put all my hardware specific code in here so that my web app doesn't have to have all that code. There's nothing stopping me from, in this main.py, instead of rendering this template, I could go call different functions to interact with my Raspberry Pi hardware. But I like to kind of keep this separated so that my web app code is all about how to render my my kind of state and how to interact with the hardware, but it doesn't actually have that code. So I want to separate that hardware specific code out and put it into like this thing.py. And the two things that I want my thing to do, so I want it to expose a way to set the LED, like to turn it on and off, and then also to read the switch that I have connected to this. So I'm going to use the rpi.gpio library. So it's a really nice little library. The website for it is here, and I'll put a link in the description below to this. But it's kind of the standard one that almost everyone uses on the Raspberry Pi for accessing Python stuff. And so I'm just going to copy out some of the code for talking to this device. So let's start out. We'll import RPI GPIO library. Now I'm going to create a class just because I'd like to keep things kind of isolated. And I'll show you, I'm going to create a test file that tests the code I write in this file here. And so it's useful to create a class because then I can create an instance of it and I can call functions on it. I could just put a bunch of global functions in here, but I'd like to separate things out and kind of make it cleaner from the start. So I'm going to make a class and we'll call this pything, and it inherits from object. So this is just the Python way to define a class. It's a new style class. Generally you don't need to worry about this. All of your objects in Python should inherit from object in most cases. And then we'll give it a doc string, and we'll just say this is Raspberry Pi internet thing. Oops, internet thing. Maybe not the most descriptive doc string in the world, but that'll work. And then it needs an initializer, so we create an init function, and this takes a reference to itself. This is just standard Python stuff. And we'll come back, we'll fill in what this does in a second. And now I think there are two functions I want to add to this. So like I said, I want to be able to read the current state of the switch and set the LED. So I think that both of those should be their own function. So I'm going to add a read switch function, and this just takes self. So that's just the convention in Python. Every function inside of a class, every class member function needs to take as the first parameter self, which is kind of a reference to the class that's passed in. And then the switch function doesn't take any other parameters. It's going to return a result that says like whether the switch is on or off. We'll come back and I'll fill this in a second. And then I'm going to add, how about a set LED function? And this one will take a parameter. So we'll take a value parameter. and this will actually turn the LED on and off with this. So let's see, let's put doc strings in. So we'll say change the LED to the passed in value, either true for on or false for off. And then for read switch, this will be read the state of the switch and return it as a Boolean. And okay, cool. So now I need to start plugging in the code for this. And really I just need to use like digital read and digital write, effectively from the Arduino world. And so the RPI GPIO library, it has pretty much an analog to digital read. So if you go down to its description here, you can call this GPIO input function, and it also has an output function, GPIO output. So I pretty much just need to call these functions. There's a little bit of setup you have to do first though. So you need to basically tell it, how are you numbering the pins on the board? So do you use the BCM or the board numbering scheme? And the BCM scheme is usually the one that people want to use. If you're using, I have the Pi cobbler connected to this. If you're using the cobbler, you want to use the BCM numbering scheme. The board numbering scheme actually uses like the physical position of each pin on the GPIO headers, versus the BCM scheme gives you the GPIO numbers from the Raspberry Pi's BCM 2835, or I guess the Pi 3 it's 2837, and it's the chip on the Raspberry Pi that talks to GPIO. It has a different set of numbers, and it's just it's a weird thing. If you each Raspberry Pi library seems to use a different way of numbering it. It's nice that the GPIO library, the RPI GPIO library, lets you pick which one you want to use. So to be consistent, we'll pick the BCM numbering because that's what the Pi cobbler uses. So I need to do this. I need to call this function. And a good place to do this, this is like a one-time setup, is in my initialization function here. So, this will be called whenever code creates this PyThing object. It's going to call this BCM, or this GPIO.setMode function in here. It'll do this once, and I don't need this pass anymore because I've actually got something in the function. Then there's a couple other things I need to do. So I also need to set up my inputs. I need to set up certain pins as an input, and I need to set up like the LED pin as an output. The RPIO GPIO library, it has this GPIO.setup function you can use for that. So I'm going to put a few calls in here to set up, and so we'll do maybe the first setup will be for my LED, and that one is connected to pin 23. So if I do 23, and this should be a GPIO.out, so the LED as an output. And then for the switch, that's number 24. I'll do this as an input, and we'll say switch as an input. So okay, cool. So that's the setup that I need to do, so that when I create this PyThing object, it'll configure my inputs and outputs. Now the read switch function, this one should be pretty easy. I just need to do GPIO.input and read pin 24, my switch input. And I'm going to return that result. So this is going to return a Boolean, effectively, like a true or false value that says if it's on or off. And then for setting my LED, I need to call my GPIO.output function, and I need to tell it which pin 23, and then I need to pass it the value because I'm basically saying pass in either true to turn it on or false to turn it off. So I can just pass that value directly to the output function here. So that's cool. I'll save that. And one little tweak I'm going to make right now, instead of hard coding these numbers, I'm going to create just some variables at the top to put these values. So let's say like LED pin equals 23 and switch pin, let's make these all line up, equals 24. And so that way then I don't have to actually, if I want to change these pins, I can just change them in one spot. So it makes the code a little bit cleaner. So let's just change where I use LED pin. And then let's use switch pin, and let's put switch pin here. So okay, so that's kind of the basic class. Now before I put this into the web page, I want to test this code. Like I want to see that this works because there's less stuff going on. I can debug it a little more easily if I don't have it in that web page. I want to see that this is working and then integrate it into the web page. Because a big stumbling block sometimes is, you get ahead of yourself and you do a couple things and you haven't really checked that they work, and you try and put them together and now they don't work. and then it's like, okay, what's broken? And you just have to start debugging. So try to do everything in isolation, you know, make things that are separate. Okay, so we'll save this, and let's make a new file in here. Let's make a thing test.py. And now I'll write some code to actually create my thing, my PyThing object, and call the functions and check that they actually work. Now you could, if you're a little more advanced Python, you could create like a Python unit test file and put it in here. And I'm not going to do that yet. Maybe in a later video I will. You know, for now I'm just going to write some Python code, and you know, that's okay. Like, as long as I have something to test this, it's, you know, better than nothing. Like, sure, it's not like a unit test that's easily runnable, but one tricky thing, you know, when you have hardware like this that you're trying to test, it's hard to run unit tests because you need that hardware. It might need to be in a certain state, you know, like I need these LEDs and things wired up. So for now, this is kind of a manual test, but it's still useful to have it. Okay, so the way that I'm going to write this test, I need to import my thing, which is that thing.py, so I'll call the import command. And then I need to create my PyThing object, so I'll make a PyThing variable, and we'll create a PyThing class. So I have to reference thing.pything because I've only imported the thing module. You know, I could do, like, for example, from thing import pything. That might actually be cleaner. Let's do it that way. And then I don't need to reference it this way. So okay, so I create an instance of my PyThing, and now let's call some functions. So let's get the current switch state and print it out. So let's do that. So let's get the switch state, and so now I want to call the function that I just wrote. So let's do pything.readSwitch. Oops. And it doesn't take any parameters, and you know, you might look at the file and you see, well, wait, there is a parameter here, this self, and that's something that Python does for you. So you know, because I've created this as a class, as an object, it automatically sends that self variable in as the first parameter. And you'll see why this is useful later. You know, if there's certain state that's internal to this object, you can add it to that self variable, and then you can reference it later in your functions. But I'm just going to call that read switch. That's going to return back like a true or false or a 0 or 1 value. And then let's just print it out. So we'll say the switch, and we'll use the Python string formatting, and let's just print out the switch variable. So let's save that, and let's go back and let's just run this as is. So this is only going to do the switch. This won't do the LED. I'll just hit Control-C to stop my little web app, and I should just check. Yeah, I've got the files here. So if I run python thing-test.py, and also you might notice I'm not using sudo to run this, and that's a nice little thing in the latest versions of Raspbian. Like, I think at least since this year, they've tweaked it so that by default you can access GPIO without having to run as root. So in the past, you know, you might have seen everything runs with sudo, but kind of nice, you don't actually have to have that now. So okay, I'm going to run thing test, and okay, it tells me a couple things here. So first, give me this runtime warning. This channel is already in use. This is just a weird quirk about the RPI.GPIO library, where it tries to set up some fancy stuff where, like, it can detect when an input changes state and notify you of that. But to do that, it has to kind of subscribe to some global stuff internally. And it's just kind of telling you that, hey, I was already configured to listen to this thing, and now you've asked me to do it again, and I don't know if that's right. So it throws up this warning. It tells you that you can suppress this warning, and that's what I'm going to do if you call this GPIO.setWarningsFalse function. So I'm just going to throw this in into my thing class. Like, in this initialization, I can just throw a call to that in here. That'll just get rid of that weird little warning that you see there. But we can see, okay, this worked. It says here's switch 1. So like, if I run this again, actually I shouldn't get that warning. So yeah, I don't get that warning now. Now if I move my switch over to ground, we should see the switch is 0. So switch is 0. So okay, that's cool. We see now my thing can read the switch, and it works. So now let's do the LED. So in my test for that, I was thinking I'll just go into the loop and like blink the LED basically. So let's blink the LED forever. So first I'll just print out what I'm going to do, blinking LED, and we'll say Control-C to stop. And then we'll do a loop. So while true, this will loop forever. And let's do my pything.setLED, and let's set this to true, so let's turn it on. And then I need to delay for a little while. And so the way to do that is you want to use the time module. It's a standard module in Python. So I need to import that. And I need to do time.sleep. And this takes a value in seconds. So I'll do 0.5, so for half a second basically. And then we'll do pything.setLED to false, so this turn it off. And then sleep again, so for 0.5. And so this should just blink the LED. So it'll turn it on, sleep for half a second, turn it off, sleep for half a second, and then loop back up to the top. And, turn it on, turn it off, turn it on, turn it off. Real common, kind of easy way to do some blinking like that. So okay, so now let's run this function. And okay, cool. So it told me the switch, it's still 0 like I had. And you can see the LED is blinking now. So that's looking good. And I'll press Control C and that'll stop it. So okay, cool. So I've got a thing now, and it's simple. It doesn't do a lot. It can read a switch and it can set an LED. And now I've got a little test that tells me that thing's working, and I don't need like a web framework and all that to check it out. So now let's put this thing into our web app, and let's see how to do that. So let's go back to our main web app here, and I need to do a few things. So I need to import my thing. So let's do it the same way from what was it? Thing import pything. And now let's see. I'll start putting in some comments. So like create Flask app and pything. So I need to create my pything, and we just need to create a new instance of this class. And so this is just making it as a global variable. It just lives in this Python file, and that's okay. Like this is not a complex script. Like there's one function right now. Maybe we'll add another in a second, but it's not super complex. I think it's okay to have it this way. Okay, so I've got my route. I'm rendering my index.html. Now let's start out by putting the switch state in there. So in my template, I need some way to pass it data, like to say, is the switch on or is the switch off? And they call it a template for a reason, because it is a template. Like you can plug values into this. And so Flask, and by the way, I've kind of glossed over it, but Flask, if you go to their website, in their documentation, they've got a great little quick start. And so when you want to first get started with Flask, definitely go through this quick start, because within a few pages it tells you all the basics. Like 90% of what you're going to use with Flask is right here in this quick start. But one of the really nice features is you've got this whole templating language where you can define a template, and you can give it values that it plugs into that template. Oops, let me go back to the page here. So yes, this kind of tells you, okay, you can create a template. Now there's a special syntax for the template. It's this thing, it's called Jinja 2, which is, there are lots of different templating engines. This is just the one that Flask uses by default. You don't have to use this templating engine. I think you can use other ones. But it's really simple. And the basic idea is, if you've ever done any web programming like PHP and such, you see this all the time where you write your HTML code, and then inside of that code you have some special identifiers that say, okay, now I want to run some custom logic on the server side. I want to plug in, like maybe get the state of a variable. And so the Jinja 2 syntax, they use kind of curly braces here to do this, and so you can kind of plug in code for this. So let's just start with our index.html template. And let's see, I'll change it up a little bit. So maybe we'll make it a little prettier. We'll put a header in here, an H1 header that says about Raspberry Pi thing. And then let's print out, we'll just give it some text. Welcome to the Pi thing. And then let's print out the switch state now in another header. We'll put it like an H3, a little bit smaller header here. And so we'll say switch. And for now, I won't put anything. I just want to see what this web page looks like. So I'll save this. Now I need to run my web server again because I stopped it before. So I need to run that Python main.py. So okay, so it's running on port 5000 now. So I can go back and I can access my web page. And we should see, okay, so it's rendering. I've got a little bit of a title, and then my text, and here's the switch. So okay, so now when I want to pass a value into this template, what you can do if you do double curly braces like this, you can reference a variable name. So if I reference like switch, then this is basically saying, okay, it's not going to render curly bracket. It's actually going to look and see, okay, there must be some variable called switch that was passed into this template, and I'm going to render whatever value was passed in in its place. And so there's one other little change. So now when I'm rendering the template, I need to pass in a value for that switch. And I really like Flask because you can just pass that in as a parameter, as a name value kind of pair here. So I can just say like switch equals foo, for example, and let's save this and let's see how this goes. And I just saved it. It automatically reloaded. You can see it just detected the change, so I don't need to rerun it. So when I hit enter now, it's a switch foo. So okay, that's cool. So it plugged in the value there. So now you might start to see, okay, here's how I can get my state from my thing and pass it down to my template. So in this function here, I can do other things. So now I need to get the switch state and pass down to the index template. So okay, let's do that. Let's create a variable called switch, and let's call my python.read switch, just like I did in the test function before. And let's pass that value in. So it looks a little funky here. I'm basically saying switch equals switch. This is just saying that there's a switch parameter that should be set to the value of the switch variable that's in here. And you could change these names if it's a little too confusing. So okay, so let's save that, and now let's hit the page here and see, okay, switch 0. So now let me change it to 3.3 volt power, and we should see if I reload, now switch 1. Okay, that's cool. So already I have an internet thing. I'm reading the state of some hardware on here, and it's not the fanciest thing. I have to reload the page, but we're starting with basics here. Oh, and I just saw, let's see, a question, do you have to run the script every time you want the state? You don't have to run the script, but you do have to hit the web page every time you want to check the state of this, like if I change this. And that's basically because that template and that logic only runs on the server side. So there's nothing in the browser here that's checking, what's the current state of this thing. And you can actually see in the output of the server, it's showing every web request that's made. And so every time I refresh the page here, you'll see there's a new GET request that happens on here. And so when that GET request comes in, then my Python code right here is called. And when my code is called, it actually checks to see what's the value of the switch and then renders it in the template again. And so that's why you have to refresh the page. And sometimes it's called like request response style websites, where you have to hit the page to get the new state, and when you want to write something, you refresh the page with some new state, versus like a lot of apps and things that you see today are a little more dynamic, where they'll have some JavaScript that runs in the web browser and might be talking to the web server through like a WebSocket connection where it can instantly update things. And I want to do that in later videos. We'll kind of evolve this web app to do that, but for now it's real simple. And for a lot of cases, like if you just need a simple little web app, there's nothing wrong with this request response kind of style here. So okay, so we've got our switch. Now it's showing 0 and 1. Let's see if we can make this a little bit nicer. Like let's print out like on and off maybe. And there's one way we can do this. So I could put that code in Python here. I could say like if switch equals 0, then set it to on or off or something like that. But what I want to do, because that kind of logic is more of display specific, because like let's say I want to change this web page and maybe like change the language. I want to like do this web page in German or something, and maybe I don't necessarily want to hard code into my code like, okay, well now it's in German, I need to change on into the German equivalent to that. That kind of display specific code I want to keep where all of my other display specific code is, and that's pretty much the template file itself. And the nice thing is, this template, it can do more than just render variable values. It can actually run code in here, and it's Python code, and there's some Jinja 2 specifics to it. But in this case, they have a really nice little shortcut where you can do a little if check to change a value based on the state of another value. So, I can actually say, if I want to render on, I can do that if switch is true, because it's kind of implicitly going to check, if switch is true, then it's going to return on. If switch is not true, if it's false, I can give a value to return in its place. So I can do this on, if switch, else off. And so just think of it like, it's returning or it's rendering the value on if the switch variable is true, else it's returning or rendering the value off in that case. So let's save that. And let's see how things change when I refresh the page now. So cool, it just rendered off. So I didn't need to change anything in my web app code. I'm still passing in the value I get back, but it's in my template now. I'm changing how I render this based on the state of this. And if I change this, if I connect it up to the power there and then refresh the page, now the switch is on. So okay, that's cool. I think we've got the reading the switch working pretty well. So let's do the LED now. And now this is interesting because now I need to send from the web page some message that says, okay, turn the LED on or turn it off. And the way I'm going to do that is I'm going to create a new route, and this route will be for the LED. And so if I hit this route in a certain way, I'm going to have it turn on, and if I hit it in a different way, I'm going to have it turn off. So what I'll do is I'll start with just copying the current route that I have, and this is just a Flask convention. You have to do this app.route to define like what path you use, and so I'm going to say let's make this /LED. And now this route actually needs to take in a parameter. Like I want to know, should I turn it on or should I turn it off? And there are a lot of ways you can do this in web apps and in Python. I'm going to do this in kind of a REST style where sometimes you put your state into the URL that you're using. So I need to create a variable here that I can read from the URL. So the way you do that in Flask is you can actually use angle brackets to say, okay, I'm going to create an LED state variable here. And so this basically means if the browser accesses /LED/something, it's actually going to pass that something down as a parameter to my function down here. And I'm actually going to change this function. Let's call this LED. The name of this function really doesn't matter. I mean, the route is actually what defines what's accessible from your web browser. Like this one's actually called hello. Maybe we'll change this to index just to be a little more descriptive. But okay, so now this is great because Flask is going to take care of like parsing this out of the URL. It's going to make sure that there's some kind of LED state variable here, and then it's going to pass it down to my function here. And actually, I won't put anything into this function just yet. And you can actually do an even nicer thing with Flask. I can tell it that there's a certain type for this variable. So this is an integer. Now Flask will actually do some error checking to see, if I try to do /LED/foo, and we'll try that once I start this, it can just throw an error back because it knows that, hey, I expect an integer value in here. So maybe let's not even put any code. Let's just return hello in here. Actually, how about this? Let's return hello and plus the LED state that's passed in. So this should just kind of render back what we got. So I just saved it. It just reloaded it. So now, I can go back. Nothing changed on our main web page. It's the same thing. But if I go to this /LED, and let's just try 1. Let's see if this works. So it just failed. So it looks like I tried to can't concatenate string and int objects. Python sometimes doesn't like to do what I just tried to do. So let's do a string format. Let's do format LED state. That's kind of the annoying thing. When you're writing an app like this, you're going to do a little bit of JavaScript, you're going to do a little bit of Python. In JavaScript, you can concatenate strings and ints, like that's kind of the way you do it. In Python, you can't do that, so you kind of have to context switch a lot in your head between languages. So I changed that. Now let's hit this page, and okay, hello 1, that's cool. So it parsed out our variable. If I put like 1,000 or 100 in here, hello 100. Now if I do something else, like let's do hello foo, now it says not found. And so basically that means that the Flask framework was smart enough to figure out that I passed in something that's not an integer, so this route doesn't apply to it. So that's kind of cool. Like that at least helps me. I don't need to do as much error checking in my function here because I know I'm going to get some integer value passed into me here. So okay, for this now, let's just make the logic really simple. If the LED state is 0, then let's turn it off, and so we'll say pything.setLED false. Else if it's 1, then let's do pything.setLED true, so we'll turn it on. And then let's do an else in here. If you sent something else, let's return an error in some way. And now how you return errors is a little interesting, and it's might not be super intuitive. But basically, in HTML and in web pages, there are error codes or statuses that are returned. And when you hit a web page, there's a common set of status codes, like a 200 OK, for example, it means that everything went fine. Or like when we saw this not found error, there's actually a status code that's returned, a 404 not found. And so programs can look for that status code. They don't have to parse out text like not found. So if you don't pass in a 0 or a 1, I want to return some kind of an error code. And the way you do that, you actually return a tuple in Pi or a tuple in Pi, which basically just means two value or multiple values. So there are two values. You can pass back a string of like what to render, and we'll just say, let's give an error unknown LED state, and then the second value is the status code to return. And so I'm going to return a 400 status code. And if you're curious, you can actually look HTTP status codes. If you search for this on Wikipedia, so the list of HTTP status codes, this goes into all the different codes. Typically 400 level codes are errors. So 400 means bad request, which usually means like you sent in something that I don't know how to process, which is effectively what this error means. You passed in some LED state value that I don't know how to deal with. So I'm just going to return back an unknown, 400 bad request error. Now there's one other last thing. So in the case where you pass in a good value, we're going to set the LED state, but then it's going to keep going. And Flask would normally complain unless I return some kind of a good result back. So in the case that everything works, we're going to return actually no message, just nothing, and we're going to return a 204. And 204 means not modified. If I go back up here, or no content, sorry, which basically just means that whatever you tried to do succeeded, but it has no result. And that's okay. That's what I want, because you're passing in, hey, change the LED to true or false, or to on or off, and I just want to know, did that work? It's not going to return something like here's a new web page to render, for example, in this case. So okay, so I'll save this, and now let's see what happens when I change the values of this. So let's go to LED 0. So it's connecting, and something just went wrong. I just noticed. So tried to reload my page, but looks like I have a mistake here. So it's telling me that my else clause, I probably forgot the semicolon here, or the colon. So add that now, and that actually crashed the whole Flask web server. So we'll just run Flask again and get this working. So okay, so now let's hit this, and it looks like it's running. It loaded this time. So now let's hit LED 0, and this won't really do anything. Like we don't see anything. And now if I do LED 1, I should see. Okay, now the LED just came on. Let's do LED 0 now again, and it turns off. So that's cool. So I've got basically if I do a web request against this URL, then it changes things. Now there's one little change I want to make, because this is effectively an API that I've created. I have this /LED path, and right now it's doing a GET request, like it's trying to read the web page. And for an API like this, like you can see, I'm not returning any data. Like you're not really reading something. You're trying to change the state of something. And there are different methods you can use in HTTP or the web protocol. And I'm just going to define this in my route. You can actually restrict a route to only a certain set of HTTP methods. And I'm going to restrict this to the post method, which is basically a method you use when you're sending data from the web page to the server. And it's actually a really old method. Back when you would have forms that were submitted, the post method is what was usually used. There are other methods, so there's you can have like a put method. There's delete, all kinds of different verbs you can use for things. But because I'm changing the state of this LED, I'm going to use the post method. Get doesn't really make sense because I'm not reading anything, but post makes a little more sense. You might argue that put maybe makes sense too. Put sometimes implies that you have some data that you're trying to push to something. But I'm going to use post because it actually makes my JavaScript code a little bit simpler in the web page, and I'll show you why in a second. So we're going to restrict this to post. Now the interesting thing is, I just saved this, it just reloaded it. I'm not going to be able to control it from the web page like this anymore. So if I go to this /1, you can actually see it fails with the method not allowed. And that's because now that I'm saying I only take a post request, it's not going to listen to the GET request that the browser makes, because when you hit a URL in the browser like this, it's making a GET request internally. But I'll show you. We'll make this work in the web page. So we'll have the web page send this post request in this case. And actually, we could actually try. You can use the curl command. So let me open a new tab. This is on my Macintosh machine, and I think I have curl installed. Okay, good. Yeah, I do. So if I do curl, and I think it's data I have to supply. I think /data, and I think I just give the URL. We'll see how this goes. Raspberry Pi 5000 LED 1. Let's see. No URL. Okay. Let's see what the syntax is for this. Lots of options in curl. So let's see. Okay. So I want to give it options and then a URL. Okay. I guess it's because I have to pass in some kind of data. So let's just pass in just like an empty string to this, because there's no data that I'm trying to send. I want it to do a post request. So there we go. So now you see the LED just came on, and if I change it, my path to LED/0, now it just went off. And so what's happening, and you can actually see, here's the log of the Flask web server. Here are the two requests that were just made. And so now you can see here's a post to LED1 and a post to LED0. So that was from the curl command there. So that's a good, kind of easy, quick way to test things. So okay, now the final thing. Let's get this into our web page. So I want to add some buttons, and when I press an on button, I want to have it send a post request that turns LED on, and the same thing for the off request. So let's add some buttons here. First I'll make a little paragraph to hold these. And then let's make a button and type equals button. This I found is kind of needed, because if you don't have this, JavaScript tries to interpret the button as like a form submission, and you don't really want that. I'm going to give it an ID, and so this is how you can uniquely identify an element in a web page. And I'm going to call this LED on, and then I need to give it some text, so let's just say LED on, and we'll close this button. And I'm going to do the same thing for an off button, so we'll say type equals button, and ID equals LED off, and we'll just give it some text. So okay, now I have two buttons. They don't do anything, but let's just refresh the page to see what they look like. So okay, there's my LED on and off, and you can see there's not much going on. Now a really useful thing when you're building a web page, you probably want to turn on, especially as you start to do some JavaScript, turn on your JavaScript console, and so this will actually let you see output. And so let's actually put some JavaScript code that takes some action when these buttons are pressed. The way I'm going to do this, I'm going to use jQuery to do this. So I'm going to create a little script tag at the end here. And there are a lot of ways to do this. I'm going to put my JavaScript in line, right into my template file. If you're really building a web page, you probably want to put your JavaScript into a separate file so the browser can cache the file and all this stuff. But this is simple. I don't need to get fancy. Now the convention in jQuery, so there's the $sign function, which gets an object, and there are all kinds of objects you can get. It gets it from the document object model that the web browser creates. Now the document, this is kind of the root object, and there's a special ready function that you can call. So when I call this ready function, it actually takes a function in as a parameter, and it's going to call this function when the web page has loaded and it's ready to go. Because it's kind of a stumbling block. If you're not familiar with web pages and HTML, everything kind of happens asynchronously. So, as the web page loads, the browser only sees, the beginning of the file. And so as it sees more and more of the file, it does more and more stuff. And it tries to render the page kind of as it reads the file. And so one thing that you might run into is like, if I put some JavaScript up at the top of the file, it might try to manipulate stuff in the web page down here that hasn't finished loading yet. And so then you get these crazy race conditions where like you hit the web page and sometimes it works and sometimes it doesn't. So this ready function basically says, okay, wait for the page to finish loading and then call a function that I pass in. And I'm actually just defining that function in line. And this is all just standard jQuery stuff. So if you go to jQuery's website and read like some little tutorials on it, you'll see more information about this. But it's a really common convention of, you don't do any JavaScript until the page finishes loading, and you hook into this ready function here. Okay, now I want to actually attach some logic to these buttons. And so I'll do some more jQuery to do that. So I'm actually going to grab a reference to the LED on button. And so this kind of weird syntax, this is saying, okay, find the object in my web page that has an ID value equal to LED on. So that's what this hashtag here means. It means grab an element based on its ID. And so each element can have a unique ID. And so I'm basically referencing this button object here. And then jQuery has a function called click that lets you say attach a handler to call some JavaScript when that button is clicked. And this again takes another function in. And it actually takes more parameters than I'm using here. And you can look up, if we just search for like jQuery click, you'll see here's the documentation for it. And the jQuery docs are pretty nice. Like they give you examples on how to use it. So, you can call this click function and then it's going to run this code when you do the click. Now you actually can put this code like, HTML has a concept of like an on-click handler. I think it's called on-click. I don't use it because, as you build a web page, things start to get so advanced that usually your HTML file has, just how to display your data, and then your JavaScript files attached to that HTML data and add extra logic. If you try and jam out all that logic into your HTML file, it turns into a big mess of code. So that's why I try to have a big separation here between what's rendered and what's the actual logic of the page. So when the LED is clicked, let's just do a console.log. So this is going to output some debug text basically. So we'll say LED on, and let's do the same thing for my off button. So we're going to attach to the LED off button. So LED off, oops. And we're just going to do the click function again. And this is all just kind of boilerplate code sort of. And we'll just log again. So we'll say LED off. And okay, so let's save that. And actually the server doesn't even need to reload because it's going to reread my template every time I hit the web page. And so let's go back to the web page. Let's hit this. And now, so I've got my debug console turned on over here on the right. And when I click LED on, now we see, cool, there's the LED on output. And when I click LED off, on, multiple times, off. And so this is showing me. So, okay, cool. So I've got my code running now in the web page. I've got pretty much almost all the JavaScript done. And now the last thing, let's actually make a post request to that special LED path that I created. And luckily jQuery has a little handy helper function here that we can do. So you can actually do $.post and then just give it a URL that you want to post against. So I want to post against /LED, and to turn it on I just want to do a 1 in this case. And then same exact thing but a 0 for off. And this post function, again, you can look at the jQuery docs for this. So jQuery post, it takes in more parameters, but I don't necessarily need them. Like, it can actually return the results back of your post request, but for the simplest post in the world, I'm just going to pass in the URL that I want to post to. Now the URL, I don't need to specify the whole Raspberry Pi in here. If I just give a /, then it's going to use the web server that it's running on. So the browser already knows to use Raspberry Pi port 5000 in this case. So okay, so I save this, and let's hit our web page again, and let's see what happens. So okay, so I reloaded it, and I click LED on, and oh, look at that, LED just turned on. LED off, turn off, on, off. That's cool, that's working. Let's test our switch. So I'll change the switch back to ground, and now I reload the page, and switch is off. So that's cool. And now let's just try the button again, and on, off. So that's pretty cool. We've got kind of two-way communication here now, and it's not the fanciest thing in the world. It's a pretty bare bones web page, but you can imagine, like, maybe this, instead of being an LED, was hooked up to like a solenoid that locked or unlocked something, or maybe you are reading different state. Maybe you're reading like a door sensor, and you can you hit this web page and it tells you if the door is open or closed, for example. So that's pretty much all I wanted to cover for this first little example. And you can kind of see, like, here's the main code for it. It's just these two functions using the Flask framework. So there's, one function that renders our web page route. another function that defines our LED route, so you can turn the LED on and off. Very simple to read code. Like, there's not a lot of overhead here. It's, the Flask framework is doing a lot of the work for us. It's parsing out the values. We're changing our LEDs based on that value. We created our thing object, and the nice thing is, like, notice how this thing code has no reference to Flask at all. There's no web specific stuff in here. This is literally just changing the state, reading the buttons, and that's great because I can test this in isolation. I don't have to start up the web server, hit the web page, fiddle around with the inputs, make sure they're working. I can write my own little test function here that just creates my class, calls the functions, checks that they work, and it might seem like it's unnecessary right now, like I'm just writing all this code, but as things grow, you really want to have a good separation between, what is the core logic for your program? Can you deal with that in isolation? Can you test it in isolation? And then have your web logic and have it use all of that functionality that you created and import it all in there. So I guess if folks have questions, maybe throw them into the chat, and maybe I'll answer them. And like I said, this will be kind of the first video. So the next video, I think we'll kind of go further, and I want to play around with something I want to show off is how to make a little bit nicer looking web page. So I'm just using raw HTML right now, and I'll show you how I use like a framework like Bootstrap, which is it's like the framework that everyone uses. And you'll see as you use it, every web page that uses Bootstrap seems to look the same. But I think that's okay. I'm not a designer. I'm not a front-end person, like I said. I know enough to be dangerous, but Bootstrap gives you really nice looking results without a lot of pain. So I'll show maybe another video how to make it fancier. And then the other thing I really want to show is how to make this page more interactive. So like, right now you saw how I have to refresh the whole page to read the switch values. I want to change it so that the web page is actually constantly being updated. And I'll show you in future videos how you can do that with Flask. And there are a few different ways you can do it. There are a couple different methods. There's a server sent event is one thing that JavaScript can use, where the web page, the Flask app actually can just push a bunch of data down to the web page just constantly. Like, it can just say, here's the switch state. And then the other way is like a WebSocket, where you can have a two-way communication, where JavaScript on the web page reads like data that the server pushes to it, and can also send data, like if it wants to set the LED state. It'll get a little more advanced, but you can kind of see how to do some of that in later videos. And I also want to play a little bit more with making this a little bit easier. And actually that reminds me, there's one extra thing I want to show before I end this video, real fast. I'll show you how to turn this in, how to create a service to make this thing start up on boot. So like right now you saw I have to run the server. So like, if I'm not running, I just press Control-C to stop it. If I try to access this web page right now, like, the web browser, it says connecting, and it's going to spin for a while and wait. So let me show you real fast how to run something on boot. And luckily, I don't have to do a lot of this because we've got a little guide on the Learning System I'll put a link to. So this is how to run things on boot. Now, it has a few different instructions. There's some instructions for the old way. The new way to do it, ever since the Raspbian Jessie operating system, you want to use systemd, which is kind of the new Linux kind of management process. And so I'll show you real quickly. And when you search for systemd, you're probably going to find Flame Wars on it. It's a big thing. It's new, and there's not a ton of documentation yet. But at its basic core, it's really not that complicated, and you'll see it makes things a lot easier. So to use systemd, I need to create a service file. And I'll show you. So systemd actually, it has all these service files. They're under the lib systemd/system directory. So you can see all of these files, this like .service. And so these define different things that are running. Like here, here's ssh.service. And I can actually look at the state of this service. So the way you interact with systemd is the systemctl command. So if I run systemctl status ssh.service, that's going to tell me a little bit about the SSH service. So it's loaded, it's running, tells you kind of what program it's running. It can give you some log info for this. So I want to make my own little service that runs my program on boot, and so that systemd knows how to do that. And you can actually look at that .service file. So if I cat out the file, lib systemd system ssh.service, you can see what it looks like. So it's like a little INI file. So there are a couple different sections here that define how this thing works. Now check out the tutorial. Brendan, who wrote this, did a really nice little thing on this. And this is basically the kind of bare minimum system file right here that I'm just going to copy this out. And I'll create this in my web app, but I'll show you we have to move it over into a directory for systemd to use this. So let's put this up in the part1 directory, and let's call this pything.service. And I'm just going to paste in the example from the tutorial. Now let's change things a little bit. Let's give this a better description. We'll say pything is my description. This is just text that systemd will print out. So like, the SSH service, it's telling me, this is the description, the OpenBSD secure shell server. So, make it kind of descriptive. Now this is actually the thing that I want to run. This exec start is, it's going to run some code. And you actually kind of need to explicitly specify everything based on where it lives. Like you can't just say Python. You need to say, oh, well, actually Python is under user bin Python. And then I need to point it at my file that I want to run. And so my file is under the home py part1 and then web app main.py file. Now the standard output null, I'm going to remove this. This basically means like if there's any standard output from this Python script, just dump it off and forget it. But I actually like to keep it. And so by default, systemd will actually grab the output of your script. And so if it has like an error message, it's going to throw it into the system log. Like there's this journal file, and we won't look at it right now, but it's a good way where it'll actually capture the output. And so if something fails, if you reboot your Pi and your server's not working, you can go into that journal and you can see, okay, what's the output of my program. Now this install wanted by, this actually says, okay, when do I start this thing up? And so it basically means that when this multi-user target is active, now I can start this script. It's a little weird and complex. This basically means after my Raspberry Pi has booted, then it will fire off anything that depends on this multi-user target. And so this basically means that, okay, your Pi has booted and it's gotten past like initializing the network. It's booted enough that a user could log into it. And that's usually what you want. And, then you want to start running your scripts, because if you run your script immediately at boot, like the internet services might not be brought up yet. So, generally multi-user target is what you want. This alias, I don't actually think it's necessary. It just gives you a different name to refer to the systemd file by. But by default, it's going to be called pything.service. So I'm going to save this. And now let's see if I go back up a directory to where I saved it. So there's my pything.service. I have to move this file into the systemd service folder. So I need to copy this, and you have to do it as root because you can't access it as the Pi user. Copy this into lib systemd / system. I think that's it. Yeah, system. So copy it into that folder. Oh, duh, I need to actually specify the file. That might help. Let's say pything.service. So, okay, so now I'm going to copy pything.service into the lib systemd system folder. And I can just double check that. So if I lsl lib systemd system, then I should see my pything in here somewhere. So if I go up a little bit further, no, not too fast. Oh, come on, Mac. This thing's a little bit laggy for some reason. There we go. So there it is, way at the top there. So pything.service. So it's in there. Now it's not turned on yet. So like I can actually do systemctl status pything.service. And it's telling me, okay, it knows about it. It sees that there's a thing, and it's, here's the description, my Pi thing. It's loaded, but it's inactive. And so what I need to do, now if I want this thing to start up on boot, you can use the systemctl enable command, Or if I just want to start it right now to just test it out, you can do the systemctl start command. And you have to do this as root. So we'll do sudo systemctl start pything.service. And so now, okay, it just ran Python. It's not going to show you anything because it's running in the background. But let's do the status again. So if I do this, and it says, okay, it's active and it's running. So now let's hit our web page, and we should hopefully see this thing work. So I hit this, and okay, there it is. That's cool. Now if I hit LED, like it's on right now, so if I press off, it goes off. That's cool. On, goes back on. So all right, that's cool. That's working. Now if I want to stop this, I can do sudo systemctl stop pything.service. And now it killed it, and I can actually test that if I hit the web page again. We'll see it doesn't load, so okay, that's cool. Now the magic thing, when I want to make this thing run on boot, I want to do sudo systemctl enable pything.service. And now it says, okay, it made some symlinks because it's looking to see what's that wanted by value, that multi-user target, and it's going to put a little symlink in there so that when it boots up and it gets that multi-user target stage, it goes and runs my thing. So okay, now the magic thing, let's reboot, and hopefully without even logging into my Raspberry Pi, after it boots up, the web server should be running and I should be able to access it. So I don't need to go in and run my script. So let's just run sudo reboot on the Pi, and let's see. So we'll give this a second or two, and it is the Pi 3, which I've noticed it boots really quickly, like within a few seconds or so. So we'll give that another second here. And then I see the light flashing a little bit. All right, let's try and hit the web page. It might be ready now. So, hey, there it is. So I didn't even log in. Like you can see, it's not connected. I didn't run anything. Here's my web server. Now I click LED on. LED turns on. Let's change my switch. We'll go back, change that. Let's refresh the page. Switch is on now. Turn the LED off. So cool. So that's all working. So that's basically what I wanted to show in this first little, video. Just build a basic web app, have it interact with hardware, turn it into a little service. So this Pi is an internet thing now. Like, I can take this Pi somewhere, plug it in, connect to the network, and suddenly I can turn the LED on and off, and anyone could hit this. So I think that's it. I didn't see any questions in the chat, so thanks everybody for watching. Let's see, maybe I'll jump back to the previous shot here. So thanks a lot for watching. Definitely subscribe to Adafruit's YouTube channel, and you'll see this video up there and a lot of other projects and things. And then also subscribe to twitch.tv/Adafruit. You'll see where I stream these things live. And so thanks a lot for watching. Have a good weekend, and I'll be back Monday. I'll probably do another Raspberry Pi stream. And then Friday next week I'll do part 2 on this. And like I said, we'll just kind of keep building on this and extending it further, and adding more and more internet thing logic to this. Make it a little more advanced web page. Maybe make it interact with devices. Like some I2C and SPI hardware and stuff like that. So thanks a lot for watching, everybody, and I'll see you guys later.